We all know that circular references between modules are bad. Very bad. Truly, a design flaw. But are they always an indication of poorly structured code? Imagine modeling a road network where localities are cities and towns connected by routes, and a route is a fancy term for a road between two localities. In other words, we're creating a simplified graph. For convenience, we assign a label or a name to every node and every edge, even though, technically, every node can be fully described by references to incident edges, and every edge can be completely represented by the pair of nodes it's connecting. Settlements in this example are implemented as instances of the locality class. The initializer sets the name of the place and creates an empty list of routes stored as the road's property. The overridden Dunderstr method will take care of printing out the locality in a readable format. The route class is responsible for representing a road. It is initialized using an identifier conventionally called a number, even though in many countries route labels also contain letters. The initializer also accepts an optional starting point and an optional endpoint. Both are localities. In addition to assigning them to the self.start and self.end attributes, it appends the newly created route instance to the locality's list of roads. This is how a connection between a locality and a route is established through the route initializer. Here, we have to override the dunderrepper method because we're planning to print out lists of routes, not individual instances. You may have already noticed the dangerous spots where the circular reference will have the opportunity to raise its ugly head. Our classes refer to each other in the type hints, and soon we'll have to work hard to allow them to do so. At the moment, everything works just fine. We're able to create localities for 2 towns in West Angola and a road, Route EN110, connecting them. Additionally, we create 2 other routes that start in each town, but we don't need to specify where they lead to. The printout of the locality instances will confirm that our classes properly refer to each other. When we run the main.py module, we get expected output, both locations and their adjacent routes. Nothing to worry about, huh? Dark clouds start to gather above our heads when, in anticipation for the codebase growth, we decide to structure the code. We would like to place each class in a separate module, the locality class into the locality.py module, and the route class into the route.py module. Now we'll have to deal with imports. But how? Clearly, the interpreter won't allow us to simply import the necessary class from the corresponding module. Trying to run this syntactically correct code, we receive, unsurprisingly, an error message informing us about a circular import. Strictly speaking, we don't need to import classes until right before the point where we are about to use them. By simply deferring the imports of the route and the locality classes, which means importing them inside the classes that reference them, we solve the problem and allow the properties to be type hinted like before. Note that in the locality class, we can put the import statement into the body of the initializer, because that's where the type hint is. In the route class, on the other hand, we have to place the import before the initializer, because type hints are present in its signature, which means they are evaluated much earlier, way before the class instantiation. Unless you insist on keeping all your imports organized in one place, at the top of the file, this is a valid, working solution. Alternatively, we could utilize the power of Python packages. We have reorganized the code and introduced the entities package that will contain our classes and serve as a namespace for imports. To achieve the goal, let's make use of that dunderInit.py module, which is currently empty, but is nonetheless executed when the package is imported. Instead of leaving it empty, we'll import the locality and the route classes inside the dunderInit.py module in the entities package, thus bringing the class definitions into the package namespace. This allows us to import the classes in the main module via the package, instead of importing directly. In the class modules, instead of importing individual classes for type checking, we import the whole package. Python doesn't see a problem in importing a partially initialized package, as long as we don't attempt to use the attributes that are not yet in the namespace. This is the case with the route attribute, because the type-hinted line is only executed when the initializer is called, which we can easily confirm by a successful run that shows the same output as before. In the route class, the situation is quite different. Here, type hints are used in the initializer's signature, which means they are evaluated during the import. We happen to bring the locality class into the namespace first. That's why this configuration succeeded. Try to swap the imports in the dunderinit.py module, and we get the same old attribute error due to the circular import. Keep this in mind when you're trying to get out of the labyrinth of circular dependencies using packages. Were both our type hints in the method's parameters, we would fall flat on our faces at the first attempt to mention a missing attribute from the partially initialized module. Finally, there's another, more efficient way to handle the circular imports problem, by using forward references. As described in PEP 484, types can be expressed as string literals, and this is a common use case for forward references. Note, though, that even if the class name is represented as a string, the IDE may report about the unresolved reference unless, like us, you turn off the error highlighting in your editor. To keep the type checker in the IDE happy, you can import the route class during the type checking phase. The same applies for the locality class in the route.py module, which we can edit in a similar way. This method has its implications, though. In the route's initializer, we can no longer use the OR operator between the locality and the none, as this operand is not supported between a str and the none type. As a workaround, we could stringify the whole type hint expression or fall back to the good old optional or union from the typing library. All that is left is to make sure everything is working like before. Like with any other technical problem, every solution to the issue with circular references in Python is just another set of engineering trade-offs. Deferred imports are robust and easy to understand, but yield somewhat messy code with imports scattered across the codebase. Imports via packages are sophisticated and elegant, but brittle or even impossible with type-hinted method signatures. Forward references clearly separate type checking from code execution, but look somewhat hacky and require workarounds or fallbacks when it comes to the latest language features. Choose the one that works for you, and don't allow purity to frustrate the practicality of your solutions.